right, guys. So yesterday, you worked on the basics of putting it in the correct order, which hopefully that was a nice review. You worked on how to tell if it opens up or opens down, right? If it's going to have a maximum point or a minimum point. And then you also worked on finding the vertex, that point where it either goes up to go down or go down to go up, right? That vertex point. All right, so today we're going to focus on actually graphing them, okay? So before I kind of show you step by step, let's just kind of graph the old-fashioned way. So if I have y equals x squared, right? Way back when you first learned how to graph, you always made an xy table and you just plugged points in. So that's where we're going to start. Okay? So typically, where do you think you want to kind of plug points in from? What kind of points do you want to plug in? 0, 1, 2, 3, 4? That's probably where I would go. I would at least look at it from the negative side and the positive side. Okay? So let's try that. So I like things to be in order. So -2, -1, 0, 1, 2. That way I can see on the negatives what's happening and then also on the positives. So you're going to want to make sure you have a calculator as we, maybe not on this one, but as we kind of keep going through these, the calculator will be your best friend plugging stuff in. All right, guys, so go ahead. Let's plug in all of those values. Tell me what you get for y then. If I plug in -2, what's -2 squared? -4 or 4? Is 4, positive 4. If you're using a calculator, it has to be in parentheses, remember? All right, what is -1 squared? 0 squared? 1 squared? 2 squared? All right, so let's go ahead and plot our points. All right, so -2, 4. So back 2, up 4. We have -1, 1. 0, 0. 1, 1. And 2, 4. All right, so you should end up with a graph that looks something like that. All right, so it does have that same parabolic shape that you guys learned about yesterday. Right? Did you know it was going to open up before you even graphed it? Should have. What tells you whether it opens up or down? Yeah. If your a value is positive, it's going to open up. Okay, so you should have known that when we started. All right, so what else do you notice about this graph? What do you notice about the points from one side to the other side? I heard a reflection, symmetrical. There you go. That's the word you're trying to get out. Yeah. So one of the things I like about graphing these by hand is you really only have to do half the work. Because as long as you know where the vertex is, as long as I plot on one side of it, I can always reflect it over to the other side. If I plot on this side, see how it's like 2 steps away from where the vertex is? 2 steps on the other side is going to be where the next point is. You can always just find the values for one side of it and reflect them over on the other. You know me, lazy mathematician, right? If I have to do less, I like to do less. All right. So just a reminder from yesterday, because it's really important, as long as I know where that vertex is, right, I can reflect them, I can do less work. So yesterday, you guys learned about finding the vertex. That was your -b. Be careful not to forget that negative's there. Over 2 times a, we simplified that, and then we plug it back in, right? So let's real quick do an example to make sure we remember that from yesterday. If I asked you to find the vertex on this, all right, so you're going to have what's your b value? -12. Good, it will be positive. Over 2 times my a value, 3. And from the video yesterday, hopefully you remember, be careful cleaning this up, right? Clean up the top, clean up the bottom, then divide them. So on the top, we're going to get a positive 12 on the bottom, and 12 over 6 is 2. So that's going to find your x value. How do you go back and find the y? Just plug that in. Yeah, this is where your calculator is your best friend, right? 3 parentheses 2 parentheses squared minus 12 parentheses 2 parentheses plus 5, we get -7. All right, if you have that calculator, it is real fast and real easy. Just plug stuff in. Jessica? Mm-hmm. You don't have to. You can if you want. That was me just labeling my work. Yeah, no, either way is fine. All right, questions on finding the vertex? Are we okay with that from yesterday? Okay. So let's actually look now graphing. So first thing we're going to do is we're going to find the vertex. That way we know where it's going to like go from one side to the other. Your x value is 2. You plug that back in. So 2, -2. All right, so 2, -2. Now, if it's helpful for you guys, totally an option. You don't have to. This is called your axis of symmetry. Right? We just talked about how they're symmetrical, right? It's the same on one side and the other side. So sometimes it's easier when you're plotting points to know right where that vertex is. So when you're like counting over to reflect it, sometimes it's easier to have like a little dotted line there. If it helps you, can draw it in. If you don't care, that's fine. I have a tendency to always draw it in. All right, so there's your vertex. So now we need to make a table. So this is just like we were doing before, making a table. But I want to be very specific on what points I put in. Okay, because could I put anything I want in? But technically, will any point work? Yes, I could put anything I want in. But do you want to put in 1,000,000 and try to graph it on that? Oh, I don't want to. All right. Don't we all? All right, guys, honestly, what I have found to be the easiest and the best chance of getting it to stay on your graph, right, because these are quadratics. So if you square a number, how fast does it get big? Fast, right? Like if I put in 10, that graph goes up to 10. But if I square 10, I'm up to 100. Okay, like these numbers get big fast. So we want to try to keep it on the graph. So whatever your x value is here in your vertex, I usually go 2 numbers to the right of it. So that's a 2, so I'm going to go 3 and 4. Since my x value here is 2, I went 3, 4. If my x value had been a 5, I'd have went 6, 7. Yeah, that's your best shot of getting it to stay on your graph. If it was -5, I'd go -4, -3. No, it's going up. You could go the other way because they're just going to be the reflection on the other side of it. It doesn't matter. I just go 2 either way of it. Typically, that'll just keep you on your graph. Okay? Unless you're at what? Yeah, then you're in trouble. I try to give you problems that'll stay on your graph. I try. Every once in a while, one sneaks in there, and I'm like, oh, that is nowhere near your graph. Sorry about that. All right, so here we go. So if I plug in a 3, now, did you just plug in the vertex in the last one? So you know in your calculator, you can bring up the equation you just typed, right? Trying to save you some time here. Yeah, so I think you just press arrow up or something on that. But I mean, like, yeah, okay. So you can arrow back in, right? On the graphing calculators, if you hit second enter, it'll bring that back up again. And you can just arrow back. And it's nice because I have parentheses, right? So I know exactly where I need to change the number. Change it to a 3. And you should get 0. Isn't that fun? That's way faster, right? Lazy mathematician. If I don't have to redo it, I'm not going to. Yep, just use the arrows to kind of move over within there, and you should get 6. Double check, make sure you're good with that. I mean, if you want to retype in the whole thing every time, you be my guest. Peyton, it works, right? I'm lazy. If I can do less, I'm doing less. All right, so we go ahead and plot our points. So 3, 0, 1, 2, 3, and it doesn't move. Now, if I have one here, I also know I have one. Right, it's 1 spot away from my vertex. I'm going to go 1 spot on the other side. I'm going to reflect it on the other side. I'm going to plot 4, 6. And I'm going to reflect that on the other side as well. I'm going to apparently totally miss some of my dots, or just barely touch them, and draw in my parabola. Okay. No. Yeah, I went over 4. Oh, gotcha. All right, guys, be careful when you're reflecting. Okay. Thank you for telling me that. All right, guys, when you're reflecting it, you're reflecting it over your vertex, not the y-axis. Okay, like we don't reflect this 4 spots over here. Okay, yeah, that's why, me personally, that's why I draw on that dotted line, so it's easier for me to see it. Yeah, because it's 2 spots away from where my vertex line is, so I'll go 2 spots on the other side of it. Yeah, that's why it's helpful to draw that little dotted line in. What are we thinking? Are we all right with this? Pretty easy to graph by hand? Try the next one. So what's the first thing you want to find? You did do step 3. It just says draw the parabola. You did that step and you didn't even know it was a step, didn't you? All right, so let's find our vertex. So remember that's negative b over 2 times your a. So we get negative 8 over negative 8, which is just 1. Negative what? That may be a little off. I mean, sometimes I negative 58 might be a little off. All right, so yeah, I got 6. Did you get it to work out, Peyton? Did you get a 1 for your x? That's your problem. Remember, it's negative b on the top, so your b value is positive. Yeah, negative b over 2a. All right, so there's my vertex. We'll go ahead and plot that. 1, 6. And again, I like the dotted line. You can put it in or not. That's what I'm going to reflect it over. It just helps me to kind of see that. All right, so when I make my XY table to plug stuff in, what numbers do you want to plug in? 2 and 3. Yeah. Like this one's at 1, so I'm going to go 2, 3. And then you already typed all that in your calculator, so just go back and change it. So what do we get when we plug in a 2? 2. And then go back and we'll plug in a 3. And it is negative 10. Good. So if I plot 2, 2, I'm going to reflect it over my vertex line there. It's called an axis of symmetry. And I'm going to plot 3, negative 10. The grids I give you are typically 10 by 10, so hopefully that'll save you some counting. And then we can draw this in. The question always comes up, how many points do I need? Right? Isn't that how it usually starts when you're graphing in younger grades? How many points do I have to put on my graph? My thing is going to be, as long as your points allow you to cross the x-axis, if like you have a graph that's going to cross it, please plot enough points so that it actually crosses it. Now granted, if it's below it and it's never going to cross it, then just give me 2 values in your xy table and we're fine. Okay. But like if you were going to graph something and it was like up here, then give me enough points so that it actually crosses your axis. But if it's like down here and it will never cross it, then just 2 points here, totally fine. How are we feeling with this so far? Pretty easy? Somewhat? Do you guys want to practice one on your own? Okay. All right, guys, let's take a look then. So let's go ahead and find your vertex. What's your b value? 0 over 2 times a. So we get 0 over negative 4. What's 0 divided by anything, guys? 0. How do you find the other value? You're plugging it in. So if I plug in a 0, you get 1. All right, so the point 0, 1. And again, my vertex line, my axis of symmetry is going to be right through there, just so it helps me kind of when I'm reflecting. All right, so you're going to plug in numbers. What number are we plugging in? Since this is a 0, I would go 1 and 2. All right, so if I plug in a 1, what do we get? You get -1. So 1, -1, and I can reflect that. And if I plug in a 2, should get -7. And reflect. Oh, I almost missed my... Sorry. My graphs are terrible. I'm a math teacher, not an art teacher. Oh, good. I'm okay with that. As long as your points are in the right spot, I get it. All right, questions? All right, I'm going to kind of take this one more level then, okay? All right, so how is the graph of a quadratic function related to the solutions of a quadratic equation? So your entire Chapter 4 test, you were solving quadratics, right? You had 4 ways to solve them, but you were finding x equals such and such. How does all of that relate to what we're doing now? We're graphing, but... Okay, so we solved things that were quadratic. We're graphing things that are quadratic, right? Okay. Well, let's go ahead and graph. We'll kind of take a look. There is a relationship, which is why I'm going to this next. Okay, so let's go ahead and graph this one. So let's find your vertex. You can use a V if you want to kind of label your work. All right, so my vertex, we're going to go -b again, over 2 times a. So -2 over 2. So we should get -1. So this is, right now what I'm doing is no different than the last problems we just looked at. Okay, so let's go ahead and plug that in. And what do you get for your y value? I got -9. Lots of death glare to you. Make sure you get that right. Yeah, don't lose that negative. So -1, -9. All right, let's make our x and y. No. Go off your x value. I would go 0 and 1. Let's kind of see where we're at. Okay, so let's plug those in. So 0, we get -8. So 0, -8. And reflect. Let me plug in a 1. And you got what? I got, there it is, yeah. And you should get -5. So 1, -5. Am I good on points, or do I need to do some more? Did my graph cross that x-axis yet? No. Let's do another one. What number should I plug in next? 2. Let's plug in the 2. And you get, what'd you get? 0. So choose 0. And then we reflect that. Be careful when you're reflecting. Sometimes you confuse yourself because the y-axis is right there. But it's 1, 2, 3 spots away from that vertex line. 1, 2, 3 spots on the other side. So am I good on enough points now? Yeah, I cross it nicely. Okay, so I'll go ahead and draw in my parabola. There's my beautiful graph. You're like, big deal, we just were practicing this. Why are you doing this again, right? So now let's look at it a little bit differently. Let's go back, Chapter 4. Let's solve it by hand. Okay? So my equation, I gotta move some stuff out of the way here. So let's take the same equation right here, and let's solve it by hand. If you have find some space inside your page there, I'm going to extend my page here. Hey, I gave your spots a little bigger on your paper this time, right? All right, so it says now set the function equal to 0. Okay, so it's, I can't see mine now, so x squared plus 2x minus 8 equals 0. So instead of it being y equals it, I want you to take it set equal to 0. Now it looks just like stuff that we had done in chapter 4. What method would you like to use to solve that? Really? That's everybody's go-to? I'd probably factor it. It does factor. Could you use, okay, let's real quick. Could you use the square root method? No, it's got to be x term. Could you factor it? It does factor. Can you use completing the square? Yep. Could you use quadratic formula? Yeah. So you really have 3 options on this problem. Me personally, I like to factor. It's my go-to if I can because it's faster for me. Good. It would be x plus 4 and x minus 2. Ramona's on it today. Real quick, let's make sure some of you forgot how to factor. Set up your parentheses. Your last one's negative, so your signs are opposite. Options for A, just 1 and 1, so 1x and 1x. Options for C, it's going to be 1 and 8 or 2 and 4. But we're trying to get a 2 out of that, so we're going to go 4 and 2. If you check this, that's 4x minus 2x gives me 2x, so you know that it worked. All right, and then how do we solve this? Set them equal to 0. And I'm hoping that you're starting to get to the point where you don't have to write this part down. Right? You can just solve this in your head. So subtract 4, we get negative 4. Add 2, we get 2. You're like, great, Dad, don't flip the page. I want you to figure out where's the connection. There is a connection, a huge connection. Marcus? Where's the connection between the answers I get when I solve it versus the graph? There's a huge connection here. And I want to make sure we're realizing this before we move into chapter 5. Because that's where we're going next. What line? Say that again. Where's it crossing the x-axis? It crossed at negative 4 and 2. Look where it crossed the x-axis. It crossed at 1, 2, 3, 4, negative 4. That was one of my answers. And it crossed at 2. Those are your answers, guys. Wherever it crosses the x-axis is the answers you'll get when you solve it. Yay! No? You guys, you're not impressed. All right. Are all of your answers nice and pretty like that? Gosh, no, right? You got ugly radicals, you got eyes, you got all kinds of stuff. So how on earth does all that work? Let's take a look. You know I'm going to make you look at that, right? All right. On your notes, this next problem, I decided to change it. So please cross out the problem that's actually on your note packet and change it to y equals x squared minus 5. Yes. So on your notes, change that problem. I know. I don't want one that's so nice. Because I'm trying to make you see more connections. I'm trying to further your learning. That's why. All right, so let's go ahead and graph this first, right? The directions say to graph. So if we find our vertex, so negative, what's my b value? 0 over 2 times a. We get 0 over 2, which equals 0. Oh, that's a weird parenthesis. All right, so how do I find the other part of my vertex? Plug it in, which should be negative 5. So there's my vertex, right? So let's plot 0, negative 5. So my vertex line, or my axis of symmetry, is going to be right on that y-axis. What values do you want to plug in? 1 and 2. So if I plug in a 1, What do we get? Good. Should get -4. So 1, -4. And reflect. If I plug in a 2, try again. I can do this one in my head pretty fast, so it's -1. Yeah. 2 squared is 4, minus 5 is -1. 2, -1. Hey, guys, just hang on a minute. Am I good, or do I need to plot more points? Have I crossed the x-axis yet? I haven't crossed it. So let's plug in a 3. Oh, why do I have to plug in negative numbers? If I plug in a 3, we should get 4. 1, 2, 3, and then 1, 2, 3, 4. Okay, now I've got points on the other side of my axis, right? We want to make sure that actually cross. Jessica, what happened with yours, hon? Hon, you didn't change the entire problem. I don't have a negative on this. I completely changed the problem. That'd be it. Yeah. I changed the problem. Okay, so that answers Jessica's question. What happened with her? She thought she did. She's fine. She's fine. All right. So, okay, so I have that. Now what? Where did it cross the x-axis? It crossed. Did it cross at a nice, pretty point? No, it's not pretty. But I mean, it's somewhere, like, what is that, like 2 and something? It's between 2 and 3, and it's between -2 and 3. Okay, so let's set it equal to 0 now, just like we did on the last one. Let's find out what those actual numbers are. All right, so let's solve it. So we'll have x squared minus 5, set it equal to 0. Let's see what happens. What method do you want to use to solve that? Good, square root method, right? There's no bx term. So we'll move the -5 to the other side. And then we take the square root of both sides. So what does x equal? Is there an I? You have to add the 5 to the other side first. All right, so we get plus or minus radical 5. What's the square root of 5? There is one. It's just not pretty. Grab your calculator. Type in the square root of 5. 2 point what? 2.23 bunch of stuff. Plus or minus. Where did you tell me that crossed? In between 2 and 3? You told me, you're like, yeah, it crosses somewhere in between 2 and 3. I can't exactly tell you where. It's not pretty, right? Plus or minus. So you have a positive, is that between 2 and 3? Yeah. So that value right there is a 2.23, blah, blah, blah. That's radical 5 right there. And then negative 2.23 something, something, something. That's exactly where that is. Does the radicals now have a little bit more meaning to you? They are actual numbers. Like right away, she's like, you can't do it. You can, it's just not pretty. But it is a spot on the graph. It's just not a pretty spot on the graph, but it's there. Cool, right? Some of you were impressed by that one. That was more impressive than the last one, right? All right. Take a look here, guys. Solutions, x-intercepts, zeros, roots. You've probably seen a couple of those words before, right? We've used the word solutions, right? Solution, what else is another word for solution? Answer. What's the answer? X equals, right? So what you always write, we're solving for x, x equals. You can also call them x-intercepts. What's it mean to intercept something? It's crossing. So x-intercepts means it's crossing the x-axis. Where did we just find all of our answers? A x-axis is right where it's crossing. So if I ask you to find the solutions to something, I want the answer. If I ask you to find the x-intercepts, it means the same thing. What's the answer? Where's it crossing the x-axis? If I ask you to find the zeros, what did you set those equations equal to before you solved them? 0. Okay, it means the same thing. If I ask you to find the roots, that's a word you probably haven't heard before. Square root, right? It means the same thing. I want you guys to be aware of the terminology. I could use any of those words, and they all mean find the answer, okay? Depending on what textbook, what problem, like whatever source you're looking at, they use different words. So, solution. So the solutions to the quadratic equation are the points where the graph crosses the x-axis. We just looked at that. So these solutions are called x-intercepts, zeros, or roots of the equation. Okay, they all mean the same thing. Find the answer, find the zeros, find the x-intercepts, find the roots. So if I say those words, I don't want you to go, what the heck is that? I don't know what you want me to do. Solve the darn thing, okay? That's what I want. Just solve it. Set it equal to 0, solve it, give me the answer. They all mean the same thing. You have to find the vertex before you can graph it. Depends, not the vertex. If I want the vertex, I'll say find the vertex. Yeah, because is the vertex where it's crossing the x-axis? No, not typically. Every once in a while it is, but not typically. So, all right, one last problem here, guys. So I want you to graph it, and then we're going to do the same kind of idea, okay? So if I'm going to graph, what do you find first? The vertex. So let's find the vertex. So the vertex is negative b. My b value is negative 8, divided by 2 times my a, which is 4. So on the top, we get a positive 8 over 8, which is 1. Good, good, good. All right, so from there, let's go ahead and plug in the 1, and let's see what we get. So again, your calculator is your absolute best friend on something like this. Even me, who does a lot of basic mental math, I always grab my calculator on these. Good, negative 9. So let's go ahead and plot that, 1, negative 9. And again, I like to draw in my dotted line. Not necessary, but it helps me when I'm reflecting. You guys okay over there? All right, again, if I'm graphing, what numbers am I plugging in for x? Good, I'll go 2, and I'll go 3. So let's plug in a 2. So 2, negative 5. And I can reflect it. And then if I plug in a 3, 7. Oop, I totally just counted 3 and that was it. And then reflect. Do you like the reflection aspect so you don't have to actually do extra math? Oh, that was kind of terrible. You guys better at drawing them than I am, I hope. No? All right. It's harder. I mean, I'm like large scale up on the wall up here, but all right. So our answers are roughly between negative, like 0 and negative 1-ish. And our other answer, somewhere in between 3 and 4. You guys got that? Where it's crossing somewhere roughly in there. Are they going to be nice, pretty answers? No. All right, so set the function equal to 0 and solve. Are your answers the x-intercepts of the graph? So what do we have? 4x squared. I can't see my problem. Minus 8x minus 5 equals 0. Can we use the square root method? No. Can I factor that? Glancing at it, I have no idea, but I'm going to guess no. All right? You just don't want to. You want to complete the square? It factors to a beautiful thing, yeah. It will. Or do you also want to go quadratic formula? I'll be honest. If it's me personally, I'm going to use the quadratic formula. That's where I would go. So negative b, 8, plus or minus square root b squared minus 4 times a times c all over 2 times a. Who would have thought, right? After we're done with that chapter, I'm still going to use the stuff I just taught you? Right? Who does that? So 8 plus or minus radical, no idea. 144? Okay. That's what I got. So that is 12. So 8 plus or minus 12 over. So real quick before we finish this, would this problem have factored? Look at your discriminant. It would have factored. It would have factored. I can divide all of these by bigger. 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 8 divided by 4 is 2. Stop there? Oh, no. All right, what's 2 plus 3 divided by 2? What is 5 over 2? I know it's 5 over 2, but change that to like a decimal or a fraction. That's 2.5. I know I don't typically do that, but I want you to make the connection with the graph up there. All right, and then 2 minus 3, negative 1 over 2. Hopefully you can recognize where negative half is right on a graph. All right, so we get 2.5 and negative half. Look at your graph. Negative half. And 2.5, my graph was a little off because I can't draw a line, but it should have been a little closer to 2.5 in there. Yeah. How would we factor? Oh, let's talk about that. How would you factor that? What are your signs? Last one's negative, so one's plus, one's minus. Options for A. You have 2 and 2 or 1 and 4. Let's go 2x and 2x. 1 and 5. So 1 and 5. So if I check this, that gives me 2x. That gives me negative 10x. That gives me negative 8. Does that work? So if I solve this, you'd have to subtract 1 and divide by 2. So negative half. And then positive 5 over 2. It actually wasn't bad to factor. It wasn't bad. All right. Are we seeing the connection to all this stuff? Not at all? All right. Oh, I do have one more on here. Sorry. Oh, but I know why I did on this one. You'll like this. Maybe not, but I like this. Let's take a look at the graph. So let's find the vertex. We'll do it together. I want to make sure you see the connection here. All right, so if I find my vertex, we have negative b, which is negative 12, over 2 times a, which is negative 1. There's a whole lot of negatives going on up there. So on the top, what do we have? Positive 12. On the bottom, and that equals negative 6. Now, when you're typing this in your calculator, be very careful because there's a negative. Then you'd open a parenthesis and type in your negative 6, close parenthesis squared. What? All right, let's make sure we're typing this in correctly. Because you'd have negative, open parenthesis, negative 6 squared, minus 12, negative 6, minus 39. Just be very careful how you're typing this stuff in. Hey, I got negative 3. So just be careful. A lot of times people forget that negative that's sitting out in front because it's in front of the x squared up there. All right, so negative 6, negative 3. So there's my vertex. All right, so we'll make an XY table. What numbers do we typically plug in next? Good. Negative 5 and negative 4, right? Because it's at negative 6. 2 to the right to that would be negative 5 and negative 4. So if I plug in the negative 5, I get negative 4. So let's go ahead and plot that, negative 5. And then if I plug in negative 4, you are correct. If I keep plugging in more points, am I ever going to cross the x-axis? No. So I can stop plugging in points, right? Sure. I mean, I can keep plugging in points. I'm going to keep going down and down and down. So wait a minute. I thought everything we just talked about, where it crosses the x-axis, is where the answers are. The negative one, sometimes it is. Because couldn't I have a negative 1 up above and it comes down and crosses? So what's going to happen with the answers here if I solve it? I can solve it. Let's solve it. So negative x squared minus 12x minus 39 equals 0. What's probably your go-to to solve this? Probably the quadratic formula. Let's start there. All right, so x equals negative b, which is going to be 12, plus or minus square root b squared minus 4 times a times c all over 2 times a. All right, let's type this in, see what we get. So 12 plus or minus radical negative 12 over negative 2. Good. All right, so if we do a factor tree on this, that's what Ramon did back there. He pulled out the I. Factor tree, we get 2i radical 3. Very nice. Divide them all by negative 2. So 12 divided by negative 2, negative 6 plus or minus. It's going to be just I radical 3 over 1, which I don't need. At this point, would I ask you to go further and tell me what the two answers are? Why? There's an I. Where did it cross the x-axis? It never did. So anytime, guys, I want to make sure you're seeing this connection. So if it has an I for an answer, look at the graph. It doesn't cross the x-axis, ever. So if I graph it, could you tell right away that your answers are imaginary? Yeah, if you graph it and it looks like that where it's never going to cross, your answers are imaginary. Okay? What if your answer is just a radical but not imaginary? Will it still cross? Did we look at one that did that? Remember the one I made you change? Here? Your answer on this one, we ended up with plus or minus radical 5. It crossed. Because a radical, it's just a decimal. Okay? It's just a decimal. But if it's got an I on it, it's imaginary, it's not crossing ever. Come on. Kind of cool today, right? You make that connection between the graphs and solving. There is a connection between them. There really is.